Okay. Well, good morning, everyone. Thank you for joining us. My name is Keith Diebold, Business Development with Cambridge. I have with me this morning Nathan Auker, who heads up our Applications Engineering Department. And then we also have Brittany Walters in our Marketing Department. We're going to show you a short video kind of covering who Cambridge is and what we do. And then we'll talk on the other side about why it's important to create healthy work environments.
Anytime that somebody's really looking to change the indoor quality of the building, I think that's when Cambridge can really step in and start driving the ventilation requirements of the building, as well as heating and cooling it. We're looking to actually build healthier environments for people. I mean, it kind of started with us here.
We like to do our product development, apply them in our facilities, understand the challenges that maybe we face and solve them internally, and then be able to reproduce that for others who may have the same challenges out in the field.
Now we walk out in the middle of summer, it's 78 on a 110-degree outside day. The air is amazing in here, and I think that's honestly what we're trying to do for other manufacturers throughout the United States.
The hardest thing to do is take the first step towards a healthy working environment is to really understand what your options are. Are they trying to solve for an energy goal, a sustainability goal, a decarbonization goal? Are they trying to solve for indoor conditions that are favorable to people?
We first need to understand their challenges, what they're trying to achieve, understand their facility, maybe what processes are going on inside their facility.
Because we're not just going to say, oh yeah, give us a heat load, here you go, here's your quote, off with you. We're going to actually have experts look over that design and ensure that we're going to get the best possible solution for your building.
We have built quality into our process all the way throughout the system. We test every unit to go out the door to make sure that it's functioning properly.
We test the combustion, we test the airflow. This is not typical in our industry.
Because we care deeply about quality inside our walls, that translates into, well, then let's build products that are going to last. That matters to us, and it can't just be for a couple of years. We want it to last for decades.
We talk about ease of doing business. We want to be the people that when you have a commercial or industrial space that needs heat or air conditioning, that we're the people that you come to.
Working with other companies, we're finding that there's a desire for having a low carbon footprint and stewarding our environment. And that is something that rings really, really true to Cambridge and who we are.
For all of us to know that even the little things we do every day on the line, in the office, anywhere here at Cambridge, actually leads to another business having an enriched and a fulfilling and healthy working environment matters a lot to us.
We exist to glorify God by enriching the quality of every life we touch.
We are in that business of enriching lives through this system that we've developed, but it's in our DNA, it's our big purpose, it's why we exist.
So in summary, our sweet spot is heating, cooling, and ventilating open spaces such as warehouse facilities, manufacturing facilities, aircraft hangars, just to name a few. And we have three aim points for the equipment that we manufacture. And the first is to be the most energy efficient, to have the longest lead time, and to be available with the shortest lead times in the industry. We go to market through manufacturers, representatives across the United States and Canada who are calling on mechanical contractors, engineers, and end users. And our rep partners team with our internal experts to develop building solutions that reduce our customers' energy cost, reduce employee turnover, and increase productivity and quality. So when we talk about why is it important to build a healthy work environment? It's been interesting in our industry, facilities that people didn't look to cool, specifically the manufacturing facilities. 5-10 years ago, there was a rush to cool these facilities now. I have a customer who has multiple plants across the country, and they lose 20% of their workforce during the summer months because of elevated temperatures. So the first reason that people are rushing to cool these facilities is employee retention and to attract employees. Also, the second is the physical effect that the environment has on productivity and quality. And the third reason is health and safety. So if we just step back and take a little bit of a snapshot, I'm not going to get too deep into this, but just to give you an overall view of what is the state of manufacturing in the U.S., and I'm going to couple that with Missouri because we're in Missouri to give you a little bit of an idea. Currently, the manufacturer percent of GDP is about 10.5% in the U.S., which is about $27 trillion. In the state of Missouri, it's about 11.7%, which is about $430 billion. Manufacturing employment represents about 10% overall employment in the country, and in Missouri, it's about 11.5%. Manufacturing is expected to grow about 4.5%, and they also estimate capital expenditures in manufacturing is going to grow 5%. There are 13 million workers in manufacturing, over 238,000 firms. And the 234,000 firms are less than 500 employees. So the majority of manufacturers are small to medium-sized businesses. And manufacturing is a force multiplier in our economy. For every dollar that is spent in manufacturing, it generates $2.96. And the same is true when you get on the employment side. For every job created in manufacturing, there's 4.8 workers generated in supporting industries. So when we talk about the overall labor market inside of manufacturing and why it's important when manufacturers start talking about retaining and attracting employees, the U.S. Chamber of Commerce estimates that there's 760,000 more jobs than there are workers. And according to the National Association of Manufacturers, 60% surveyed said attracting and retaining employees is their number one concern. And in Missouri specifically, we have what we call a 0.53 worker shorter index, meaning that there are 53 workers for every 100 jobs. Replacing workers due to whether it's the physical environment or other causes can be very costly. It ranges from anywhere from 6 to 9 months of an annual salary. U.S. manufacturing is projected to need by 2034 3.8 million workers, and there's a projected shortfall, according to the National Association of Manufacturers, of close to 2 million workers. So employees are at a premium. And this next chart, I'm not going to dig into this, but it does give you kind of a sense, is this a short-term thing? Is this a systematic thing that we're going to face in the coming years? And if you just look at the population pyramids, whether it's United States or Missouri, ideally you would like to have less workers leaving and more workers entering the workforce. But you see very quickly our base is narrowing, meaning we will have less people coming into the workforce and a greater amount of workers leaving. So this problem is here to stay. So attracting and retaining employees is important, but the other thing is important is productivity and quality. What does that physical space have on the effect on productivity and quality? I was working with a major automobile manufacturer. They manufacture parts for all the big automobile companies, and they were having trouble in the summer months hitting their productivity goals. In June, it started at about 12%. They'd have a fall off, and in July, they were roughly at about 18%. And then in August, the hottest month in Western Kentucky, when it was 95 degrees outside, it's 105 inside, they were off their production goals by 25%. So elevated temperatures have a tremendous impact on the worker. There's decreased worker concentration and efficiency. There's an increase in fatigue and errors in production. ASHRAE just recently did a study, and Nathan's going to dig into this a little bit more, but they estimate that for every degree over 77 degrees Fahrenheit, you lose 1% in productivity. So health and safety are a prime concern for workers in elevated temperatures in the environment. The Department of Labor estimates that accidents are 3 to 4 times more likely during the summer months. OSHA has recently come out with a recommendation that internal temperatures in manufacturing facilities should not exceed 80 degrees Fahrenheit. Obviously, heat exhaustion, dehydration, risk of stroke are huge concerns for workers. And then also increased fatigue causes accidents. And since 1992 to 2022, the EPA has said there's an average of 34 deaths due to heat exposure across all industries. So when you tie it all together and you look at your physical environment, you have to ask yourself, is it preventing you from attracting, retaining employees? Is it allowing your employees to optimize quality and productivity? Or are you exposing your employees to unnecessary risk? Creating a healthy work environment in manufacturing is essential for productivity, employee retention, and overall business success. And I think when you get to finding I've talked to many companies across the country when we start talking about cooling, and it's interesting, they get used to solving the short-term fixes. In summer, they beef up temporary employees, or they're going to crisis mode, and they start managing symptoms instead of looking at the overall taking an overall systemic approach, which leaves them a little bit short of the finish line. So what you need to look at is, what is that unhealthy working environment costing you today? And what is that impact having on the bottom line? There are dollars leaving your facility, whether it's due to employee retention, productivity. There are dollars leaving your facility today when you do nothing at all. You just maintain the status quo. I think if you go to the next one, Nathan, there are next steps that we'll talk about as we dig into this a little bit further, whether it's a facility assessment. We've come up with a pretty powerful tool on what it looks like to document the cost of doing nothing. How do you optimize existing equipment? And then also, a lot of these buildings are very complex environments. You just can't flip a switch normally and it's going to be 70 degrees inside your environment. There are steps that can be taken that can help you optimize existing equipment and take integral steps to building that facility that you kind of ideally see.
All right, thank you, Keith. I'll take over from here. So when we talk about worker productivity, Keith mentioned the ASHRAE journal study. So we look at assuming full productivity at 77 degrees for our purposes here, 1% increase or decrease in productivity over that. And so for our example here, we're looking at an outside temperature of 95 degrees, and then the inside temperature getting up to 105 based on just ventilation issues potentially, or just the solar heat gain throughout the day. And that equates to a 28% productivity loss, which is very dramatic. And as you can imagine, heat also increases turnover, and there are costs associated for each turnover. So there's absenteeism along with safety incidents and quits, and each of those has associated costs, not to mention recruiting, all of the infrastructure to screen, onboard, train, supervisor time, and the opportunity cost of this strain that this applies to a business. So back of the napkin, if you take a quarter or half of a salary for a year, 3 to 6 months, if your example is a $60,000 salary, that's $15,000 or $30,000 per employee departure. And so you can really quantify this impact by taking your quit rate, your monthly quit rate, and your salary band, and replacing that with the ramp timelines. And we'll get into this here. Just want to pause right here for a second and show a quick example of what this cost of doing nothing might look like. So right here, we've got facility in Kansas City, Missouri. This is a fake facility, but indicative of some typical facilities where you've got max indoor temperature in the summer of 100 degrees. You've got a $45 labor rate. And then you can see the associated shifts and work days. Assuming a 30% turnover rate and annual revenue and a square footage for this light manufacturing space, the capital expense to cool the facility pays for itself in 1.41 years. And you can see here the key losses that they are absorbing by taking a passive approach. So 891 K in lowered productivity that they are just absorbing. $500,000 in turnover expenses, and also some quality issues, which definitely matter, but are on the lower side of the impact. The key things here are turnover and productivity and their impact. And we have the ability, if you have an opportunity to check out what this might look like for you or someone you know, happy to run an analysis in more detail for your specific situation. So the key thing is there are costs associated with a passive approach here. And let's look into a specific application, a real life application. In this situation, there's a indoor heat exceeding 100, very similar to our fake situation. And this caused discomfort, not to mention downtime for the facility. There's also this variable process heat and exhaust from testing. And so this equated to 10 production shutdowns across summer 23, 24 due to the indoor heat index. And so their goal was a desired indoor temp of 85 degrees. So let's see what this looked like and the impact. So when we look here, chart on the right shows a pre-cooling, which you can imagine is the blue line here, and the post-cooling. And so you see post-cooling, 100% of the hours, working hours, were 85 or below, whereas before cooling, only 70%. And so that's a dramatic impact on working hours. And what we're seeing in terms of OSHA regulation is heat index of 80 is being thought of as an initial heat trigger, and heat index of 90 could be a high heat trigger. And these, you can travel to this website here if you're curious about more details, but in California, they're seeing adoption for this type of rule, and this is going to likely spread to broader areas where there are key downtimes required over certain heat indexes, which both capture temperature and humidity in a space. So let's look at this facility here. So what we're showing here is heat index spread throughout that facility. And basically, the band on the far right shows the variance in heat index inside the facility. And then you can see the outdoor heat index. As that changes, you're able to really manage what the indoor space is able to deliver, keeping even conditions for all workforce and allowing them to enjoy their work at a higher level and also be more productive. This is a different view of this same phenomenon. So on the left, you've got pre-cooling, where you see, June temperatures are ramping up and you're seeing the heat index get up to 100. And then following cooling implemented, you're seeing really steady below 80 most of the time on heat index and all of the time below 85. So dramatic impact to the workforce here in terms of how they feel, how it feels when you walk in the facility from the hot outdoor conditions. All right, and hang in there with me for those who may not be data folks. I love this stuff, so appreciate you looking through with me here. before cooling on the left, we're seeing the plant average on temperature in the top left, mimicking the outdoor weather. So you're just tracking that very closely. And then the bottom left, you're seeing before cooling, the humidity doing very similar tracking for the outdoor humidity, which makes sense. And post cooling, you're seeing in the top right, temperature, the blue temperature just dramatically below outdoor conditions. And then the real impact here that you're seeing beyond even temperature is the relative humidity, taking the mugginess out of the air, keeping that air as dry as possible. So you're seeing just dramatic improvements there in terms of pulling moisture out of the air. Let's look a little bit closer at kind of a heat map of humidity before after. So top right, you can see just visually the orange colors showing warehouse RH spread throughout the facility. In the bottom right, you see the nice blue, cool warehouse RH after cooling submitted. And so you're getting this relief for a workforce while also getting the temperature depression. And just kind of a fun facility moisture content to give you an idea. So for a 68,000 square foot facility with working hours Monday through Thursday from 6 a.m. to 5 p.m., you can see the water volume impact. So 270 gallons of water removed from a facility per day out of the air, out of impacting workforce. And it's dramatic in terms of how it feels. And there's a nice visual. All right, so when we talk about what it costs, the cost of doing nothing, the cost of passiveness towards the environment as a leader of a manufacturing or warehousing facility, a passive approach really goes to letting your environment dictate to you. And so what this is about is addressing your environment directly as a leader, and the impact here from the end users feel like for a plant supervisor here, he goes home with more energy for his family. So for the plant manager, for the leader of the facility, employee health, productivity, and morale is all improved. And then from the finance side, from the CFO seat, the payback is both clear and fast, dramatic. And so one thing to just consider here is, what is your legacy? What is the story that you want to tell as far as your impact as a leader someday to your children, grandchildren, both from a financial impact and also a real world human impact? How are you impacting people, and what is that long-reaching legacy that you can provide them by impacting their environment? So with that, just wanted to open up if there's questions. Happy to work through an example as well if somebody has a specific. Thank you so much for being here today. And if you want to learn more, please get in touch with our team. We've got Keith, his email there, and then got the applications engineering team's email below. We have a QR code here as well if you'd like to schedule your facility assessment. We'd love to engage with you and go from there. Thank you so much.
Hi guys, I'm getting some chats about just the recording and the presentation. We'll send it out to all attendees, the recording and the present and link to the presentation. So thank you guys for joining. Nathan and Keith, it doesn't look like we're getting any questions at this point.
No problem. We will be ready for your future questions, so please don't hesitate to reach out. Love to work through specific examples or a building, and see what impact you might be able to make there.
Nathan, you've ran a couple of cost of doing nothing analysis for some customers. What are some frequently asked questions you might get with those, if any?
Yeah, absolutely. So people are very interested in knowing where the biggest impact can be made, or where this makes the most sense to cool a facility. And the answer is it doesn't always make sense. For instance, if you have a facility with very low density per square foot of people, so you have just a few people in a facility in a smaller area, you may want to consider a different, more localized approach than the whole facility. But if you have a facility where you've got a density like we're seeing here on this example, it really, you can see the payback here is 1.41 years. Just for example, if you lower the density a little bit, it goes out to 2.39, but still valuable. So that density of people per square foot is a real factor here. Also, your employee turnover rate is critical here. So if you have a higher employee turnover rate, your payback, the impact you can make on a total dollar amount actually goes up. If you feel like you're in a really good spot on turnover, your impact might not be as much on the turnover side. So these are just things to consider in each example. And love to work through specific examples with people to see what impact they might make. One thing that's just interesting is we talk about 77 as the peak productivity. From a thinking about a problem solving standpoint, 77 is not necessarily the limit, or we would keep offices and those things at 77. And I know I'm not sitting in a 77-degree area today right now. And so there is additional gains. I think what you look at there is probably like the cost versus impact. So these things can be tuned from 77 all the way up to 85. We see people size equipment sometimes for 85, and they're able to get an average temperature of 77 degrees based on that equipment being sized for the peak load of the summer. So most of the time you can get 77 degrees, and that is a really good option. One other question that we get quite a bit is, I see the payback, but what's the operating cost? Like, is that just crazy? And so we can work through that with you as well. And what you'll find is for the payback, the operating cost is very reasonable, and actually not a big hurdle for most businesses. But again, each case is very unique, and so happy to work through that in detail for your specific situation and goals, really. So
yeah, I think in addition, Nathan, having a facility assessment, taking a snapshot of your current conditions and first looking to optimize what you have is a pretty powerful tool.
absolutely.
Keith, can you elaborate a little bit more on your facility assessment process and what anyone can expect when they go through that process with you?
So yeah, it is obviously doing a site visit, documenting whether it's cooling, heating, or ventilating, and what's on site. Uh, R values, roof and walls, whether it's a cooling load, and really it's kind of pinpointing where do you want to be? Do I want a facility? Nathan talked about it. 77's some of these environments is not possible. There's a lot of exhaust air going out. It's almost like trying to cool your house with all the windows open in the summer. So some of these are difficult environments, but it's really pinpointing where do I want to be on the curve? Do I want to be at 85 degrees, 80 degrees? And then what are my best options to get there? And what is the impact that it's going to have on my facility? So it's really matching the equipment to what your goals are.
Nice. Thank you guys. Nathan, while we still have you, in addition to the cost savings, what are some other differentiating features of our Apex? I know there's a great sound benefit, cooling of product, energy efficiency. Can you elaborate more on that?
Absolutely. So thank you for giving me that platform here. The Apex Air it has the highest efficiency fans. And so one nice thing about that is operating costs, of course, are impacted, reduced. You also have the ability to have very low sound with very efficient air movement. And so that's dramatic in a facility. You don't want to create a situation where you have a piece of equipment in or near a facility that's adding sound stress. You're trying to reduce overall stress to a workforce, and so you want to impact the environment positively. So keeping that sound very low is a wonderful thing. It allows for good communication and those kind of things. In addition, the ability to with a ductless system, so not having to design lots of expensive ducting and potential structural roof implications. You can have air that gets thrown way across the facility and distributes the air in a flexible manner for your facility needs from day one is really nice. Also, the ability, the Apex Air has drum louvers, double deflection, so have the ability to specifically change as your operations may change throughout the life of the equipment, change the way the air is directed to specifically meet the needs of your people or your process. And so that's just something that we've seen people enjoy playing around with and finding unique ways to get exactly what they want. So that's been great. People love the touchscreen, the ability to interact with the data, the intuitive nature on the equipment to get data logging, to pull that data, analyze it. That's been really impactful. So those are just to name a few, but if someone is interested in more, would love to break that down further.